Brian, what's an antibody?
So an antibody is part of your own immune system, and it's a molecule that gets generated to, as Andrea just referred to, a bug. So for instance, if you're infected when you're young or even when you're old, when you're infected by, say, a virus or a bacteria, your immune system learns and figures out what that new species is and develops through cellular processes, develops its own drugs that then your body remembers forever. So that's why, for instance, you get vaccinated when you're young. You're trying to teach your immune system to recognize something that shouldn't be there. And antibodies are molecules that are made by a specific type of white blood cells to help basically become your own internal store of drugs to specific diseases, like, for instance, COVID-19 or polio. People get vaccinated for measles and mumps. All these things elicit antibodies to help protect you. And so that's just sort of the body's molecule of choice for making drugs to foreign species or foreign invasions and infections.
Hey, Radical Rob has a question for Sanchita. Rob, what's your question?
Yeah, Sanchita. I know I'm pretty curious about it, and I've talked to a lot of other people too. Of the, I think, 3 vaccines that are out right now, what are the main differences between these 3 vaccines?
I guess the company is the main difference. You have 3 different companies, but I think, as I know, I'm not a virologist, with my knowledge of a little bit of structural biology, they target the spike protein. So the virus has proteins on its surface, which basically identifies your cell, and that causes the immune response that Brian and Andrea was talking about. So this vaccine is based on so the vaccines are prepping the protein in your body so that you mimic as if you are infected, but not to the stage that you can have a very serious reaction. And what happens is it's like a trailer show to the body. And then, your body makes these antibodies so you fight against the disease. So they're all based on the same principle, but they have probably differences in the amount and dosage. So, that's what I can tell you about. Does that answer your question?
Yeah,
and perhaps Brian and Andre.
Yep, definitely more information than I knew
Thank
going
you.
in. Thank you, Sanchita.
There are, as Sanchita was saying, basically you are trying to show a trailer of the infection movie, right? But you don't want to watch the full movie because that's going to be a horror show. The trailer is enough. And so the thing is that the trailers, there are 3 different versions of the trailer, let's say, right? And so you can have the one version is where basically you encapsulate a piece of information inside basically a little drop of fat, and that is going into cells. And that piece of information is similar to what your own cells would use to make protein. The spike protein of the coronavirus is just another protein. We just need to give the cell of our body the right information to synthesize the protein that looks like the spike from coronavirus. And that's what is encapsulated in this little droplet of fat. So that's one, and that's basically the Pfizer or the Moderna as the same principle. Then there's the AstraZeneca and the Johnson & Johnson. These are comparable. Instead of having the straight, short information as an RNA, as we call it, it's a little bit longer. It's called DNA. And that is instead of using a droplet of fat, is using basically an empty box that looks like a virus. It's a funny thing, right? I mean, we want to complicate stuff. And so we are using an empty shell of a different virus as a delivery system, like a little mini truck that brings the DNA, the gene that encodes for the protein. And that mini truck that is basically a completely different virus is bringing the information to make the spike of the coronavirus. But it's just a matter of what really is convenient for us to work with. And then the other system that has been used is basically to make the protein outside and then inject that into the people. And that's a little bit older version of making vaccine. And for some reason, it looks like this is not really the best based on the data that we have for the coronavirus. For other vaccine, it works just great. I mean, HBV, hepatitis B, perfect. We make a protein that's from the surface protein of the hepatitis B. We make that into a vaccine, and works just great. Coronavirus, maybe not that much. But basically, these are the 3 different trailers that we're using to show the immune system how the real movie would look like.
Cool. What a succinct description. Brian, tell me, when do you think we'll have vaccines available for kids, and what do we need to get there? When do you think that'll happen?
Well, we have vaccines available, right? I just read today that San Diego's roughly a third vaccinated. Which is
for kids,
right?
for kids. Our audience is mostly school kids. When do you think kids up to 18 or up to 16 will get it?
That's a good question. I think it's up to the companies and the FDA. I believe they're testing the available vaccines that adults are getting now and have been getting in people younger than 16. So as soon as that's proven to be safe and just as efficacious as it has been for adults, then it'll be allowed. But that's pretty much, you got to test it, you got to be safe and make sure that there's nothing unusual happening in younger people. And that's what's ongoing now. And it's the same process that was used for adults. It's just the adults were done first.
Yeah. Sanchita, I know messenger RNA has been a big topic. Can you tell us what messenger mRNA is?
Oh yeah, messenger mRNA. So you can see the name messenger in there, right? So just to give you an analogy, I used to teach kids. So we have our DNA, which is the information to make these proteins, say antibody, right? That we are talking about. So, but the path from DNA to making this protein is not direct. So there is somebody needed in between. Like say you want to write a letter and send it to a friend, you need a messenger, right? And that letter say it's a recipe. So you send a box of, write the recipe, and then you send your friend, the messenger takes that letter, takes to your friend, he or she gathers all the material that are needed, and then makes the final product. So messenger RNA has that recipe of how the protein, which is our final product here, or the dish here, is made. So a messenger RNA, as Andrea was telling and Brian was telling, is the message that's needed to make these coat proteins or specific proteins, which would be these mini trailers for our immune system to, prevent ourselves from seeing the actual horror show.
Cool.
Right? Does that explain?
Yeah, absolutely. Hey, I'm gonna bring it down a level for you guys. Let's go with each of you, and let's start with Andrea. Why did you get into science? What made you want to be a scientist?
Okay, that's a good question, really. I actually wanted to be a doctor, like a medical doctor, and that's what I am. That's my degree in Italy. And honestly, I have no idea why. That's something that I always had since I was 3. My mom keeps repeating that I always wanted to be a doctor since I was a kid. So I have no idea what really sparked that in me. But either I watched a movie or maybe I don't know, I went to the doctor's office, and there were tools on, in his office that, got my attention. And so they said, oh, that's cool, I want to do that. But so I basically kept pursuing, my childhood dream. And then when I moved from Italy to US, I actually sort of changed slightly. So instead of practicing as a medical doctor, then I ended up in research. And so I've been in in science as a researcher for the last 15 years or so. Cool. But I cannot really track it to any specific event.
Yeah, absolutely. Same question, Brian. Why science? Why'd you get into science?
Yeah, it's along the similar lines. When I was young, I guess I was always impressed by seeing the individuals in the white lab coats doing science. About the time that I was, say, in junior high, I truly fell in love with chemistry. I knew when I was in 7th grade that I wanted to be a chemist of some sort, and fortunately had that opportunity. I went to college. I really liked chemistry. I learned more about chemistry in school, especially in college, that led me down the path of becoming a biochemist. That's where I got my doctorate and did my postdoctoral research eventually, and have been able to stay. I've always wanted to do research. I've always wanted to do chemistry. I've been doing biochemistry, which is just chemistry of biomolecules, so of proteins. I've been for a career that's now almost 25 years. So it's been really fun. It's just something I've always wanted to do. And so like Andrea said, I get to live out my dream, really, my childhood dream. So.
Wow. Cool. Sanchita, same question. Science. Why science? How'd you get into this?
So, as on the same line as Brian and Andrea, I actually fell in love with physics, and I really wanted to do physics, and actually I wanted to be an astrophysicist. But somehow, I had to pick up biology. So first I was like, yeah, biology may. But then I slowly fell in love with biology, and I came to know this field called biophysics, where actually, I wanted to go see stars, but you could actually see molecules inside the cells, or you could even, like now that I do structural biology, you could actually see a molecule, like actually you cannot hold it, but you could get an image of it and work around it, develop drugs. So slowly it was just a journey of realization, I guess. And frankly speaking, I really love looking at molecules, and it just amazes me that yeah, space is always great, but also inside our body there are these machines constantly at work. We don't really understand that, right? So it's that's how I think it's been a long love story over different phases. So yeah, that I love being a scientist.
Sanchita, follow-up question for you, and then I'm going to ask the same question to all three of you, and I think we might be out of time after that. One thing that you would tell our viewers, the school kids, one thing that you would that you recommend to them as they go through school, or as they choose a college, or as they go to college, things that they should study. If you had kind of one tip for them as they go out into the world, what's your one tip? Remembering that some of our viewers are 5 and some of them are 18. So is there one tip they can all hold on to? We'll start with Sanchita, and then we'll go down the line.
Yeah, I think one thing is never stop to be wondered by things. Like, when you look around like a flower, you always think about like molecules, or like think about like life. It's alive, like all the things that we see around us. So I think it's this wonder in us that puts us into this quest of knowing what's beyond that, what's beyond this petal that we see, or what's beyond this, this, like the virus. Yeah, it's very deadly, but still there is like science around it. So I guess you have to always be curious and wonder about what's actually happening here. And that question is what it's always, you'll find always something new to look for the answer for.
Wow,
I think
great
that's
answer.
what I think.
Great answer.
Very
Thank you, Andrea.
Thank you.
Yeah, to the risk of echoing Sanchita, it's really keep your heart open to the beauty of reality. The reality that is in front of you and the one that's inside of you. And that's what has been inspiring me for all this time, and kicks my butt off the bed every morning.
Something's got to do it. Brian, one tip for our students as they go out into the world.
Yeah, I mean, it's kind of echoing the same things. I think follow what your curiosity leads you to follow. It doesn't always mean you're going to be a scientist or an engineer, but it's the curiosity that will keep you interested in what you're doing and what you like to do, and that, whether that's artist or music or history or what's your favorite thing, that's what you want to do. And hopefully a lot of the people who are listening will become scientists and engineers, because we need as many as we can.